Let's talk about cross-domain futures and specifically breaking this 20-year-old way of thinking, but doing it safely. At the moment, what we have is a system where we have low side policy and low side procurement for our low environments, high side policy and high side procurement for our high side environments, and then in the middle, we're using cross domain solutions for everything pretty much. And what that involves is complex policy application on traffic between environments. So a CDS, a cross-domain solution, is really just architectural techniques and supporting technologies used to build secure end-to-end connectivity between systems that you trust differently. The way I see it is slightly different, and that's that we can have one procurement wrapper and actually take away the low and high distinction and just have secure boxes with on box policy that tell our data and apps how to behave, that deal with attributes of who is allowed to view data, how that data is subsequently encrypted, and then actually use our CDSs slightly differently. For bulk streaming, fine, complex policy application, keep that, but reduce the load and actually just have encrypted transit. And that works the same, low side and high side. Now, I don't want to do a dry presentation, so what I'm going to do now is swap over to an app that I've built to show you what this does in practice. So this is a small functional application that I've built out. It uses the MOD design system and an adaptation of it, which I've shown you previously. I'm not going to go into this, but this is the demo. So as I said, for 20 years, we've built these ever more complicated boxes to separate information. And what I want to show you here is a different world, a world where the box doesn't matter because we control exactly who sees what at the moment they need it and make sure that no one else ever can. So instead of struggling with moving data between domains, we create this one-off encrypted corridor that delivers only the authorized slice of information to only the authorized person and then destroys itself when they're done with it. Now, something that invariably will come up when people hear about this, if they're in the know, is they're going to ask about Tempest. So let's talk about it. Tempest is the SDIP 27 levels ABC, and it covers VANEC or CRT style emanation. So that's leakage from cables, processors, displays, side channel emissions, things that can be captured externally. And the mitigations are always shielding, zoning, filtering, grounding, separation, distances. In this new architecture, because we're dealing with per transaction cryptography, attribute derived tunnels, short-lived keys, API views, it doesn't alter the physical conductive paths. So the electromagnetic behavior of the hardware, the zoning, the shielding, completely unchanged because this design is logical, not physical. So actually what we're doing is adding a layer which reduces the intelligence value of electromagnetic leakage, because even if an adversary did get close enough to extract keys, buffers, process frames, ISR segments, classification banners, it wouldn't matter for long because we use one time per transaction keys. So even if the leak happens, because each transaction is bound to attributes, bound to the recipient's public key, wrapped once and then expired, an intercepted signal, even if perfectly preserved, is cryptographically dead. So actually this is a favorable extension, not a worse one. So the first thing that we're going to do is start with a multi-classification document stored at secret. This is a common problem faced across defence and national security. Documents which contain essential information for multiple audiences tend to be held at the highest tier, and that creates latency in information flows and complexity in sharing of them. So to show this, what I've done is prepared a multi-classification document that holds information at official and secret, and also has sections that have a variety of different handling caveats applied to them. The traditional way of dealing with a document like this is either to bring more users into the secret space, resulting in multiple sets of kit, lots and lots of different clearances, some administrative delays, or that some information is simply never shared again. It just exists and no one can get to it. information is generally manually sanitized and then eventually maybe passed down to lower classification audiences after that process. So we're building in layers of duplication, administration, mandrolic systems. And this is often in systems where multiple users might see something intended only for one person for a short period of time. So what we're doing here is stopping people having access to information that they need and introducing security and data handling complexity that we don't necessarily need to do. So what we'll do is we'll take our document. So this is our multi-classification document, one I prepared earlier. And what we're going to do is process the file. So what this is going to do is actually break that file down into its component pieces by classification and handling caveat. This is not a hugely complicated bit of code to do, but what we have now instead of a Word document is structured data that we can use. We've broken it down, turned it into structured data, and everything interesting in the document is held encrypted at AES GCM 256 by default, so you'll know that that's quantum safe. And you can see this here. So we actually have our ciphertext, our section titles, those kind of things. But we know which document it's come from, we know which classification it is, and we know the handling caveat. We've also got all of the other data, like section headings and stuff like that, but I'm only showing you this. So what we're going to do now is prep it for sharing. So we are going to share down from secret. You can tell we're at secret because it's over here. So using our properly structured data with no manual intervention, we're going to share down to a user official without compromising on security. We're only going to share official classification information that is releasable to the coalition as per the caveat in our document, and we're going to give it a named recipient based on the attributes. So the information is going to be individually encrypted to them and released for a limited time only. So first thing we'll do is choose from our available documents. We know that we've only got one in the system because I've just put it there. Now what we're going to do is look at the tier that we want to release to. So we know from the document these are the options available to us. So we're going to choose release to coalition. What this is going to do as a first pass is go and check recipients with the relevant handling attributes. So that's people who are entitled to see RHEL coalition information at official. So we're going to choose Dave Smith at coalitionpartners.ua, and we're going to release to him based on his attributes and the document attributes. Now this is interesting. What we actually have here is an intercepted traffic view. So imagine that one of our hostile nation states, Russia or China perhaps, had interrupted this transmission. This is what they would effectively see. Just the ciphertext. So even if they get through TLS, all they can see is this, and we know because it's AES GCM 256, it's quantum safe, so they can't do harvest now, decrypt later. The reason they can't see it, the data packet is encrypted. It's this one-time key, so it's this slice down, release to Dave Smith, and there's a signing key on there as well, and that encryption is modular. So actually, we use an AES GCM and a certain type of key exchange here. If you want to drop that out and change it for ML Chem keys, you absolutely can. It's modular. You shouldn't have to destroy a system in order to make it safe. So that logic is built in. We'll stop the man in the middle attack. And we can see now that we've received the document. A couple of things going on here. We can see the document, we can see the section that we're allowed to see, and we can now see it decrypted. So we can see what we're entitled to see at official, at release coalition, as Dave Smith, and we've individually decrypted this. We've got our information. The other thing baked in is this timer. This information will re-encrypt in a second, and once it's re-encrypted, it will destroy itself. So there is no trace of that information in an accessible format left at official, available to anybody. That's really, really good security practice. That's perfect slice management. And actually you can see the cross-domain logic there has completely shifted. So we're not sending lots and lots of documents across a CDS and working out who can access what, or bringing loads of people into our secret environment. We're dealing with this in the most sensible, logical, rapid way. We're going to go back to the high side now, and we're going to look at how this might apply to some ISR data. For the purpose of this demo, we're automatically going to generate a 5i track and distinct NATO track, because it might be that there are two different levels of granularity in your ISR data. In this instance, we're going to keep the data within our secret platform, but we're still going to use individualized encryption and attribute-based controls to release it. So the first thing that we're going to do is generate some non-spectacular, it's just lat long and a little bit of altitude drone track data. So we'll do that. That's just going to create some for us. And then we're going to choose our view to have a look. So we'll start off with the Five Eyes view of that data. Just let it load through for a second. You can see that's quite granular, lat long data. And as I said, we might want to release that same data to partners quickly, but we might have some Five Eye sensors that we don't necessarily want sharing more broadly. So we'll look at our NATO view, which is less granular. You can see that there are less data points, same outcome, same quality of information, and let's just quickly compare them. So you can see a slight differential, same outcome, two completely different audiences, and never the twain shall cross. They can't look at things they're not entitled to see. So that's almost like real-time ISR data segregation using this same cross-domain futures process of attribute-based encryption. Now what we're going to do is move on to video. A video feed, for example, TAC. Again, the content is encrypted, but the content is also different depending on the handling caveat and the viewer attributes. So I'll show you what I mean by this. And we'll just quickly upload this video clip. The first thing that we'll do is encrypt it for storage because we want this to be real, right? But then what we're going to do is choose the handling caveat. So UK eyes only are going to see something in the video that other people are not entitled to. So you've got the video, but actually UK eyes only can see the text overlay. And you can see a really clear instruction: do not distribute outside UK Five Eye channels, for the exact location and who the team was. The safe view, the thing that everyone else can see, because we still want to share some of that data and we want to do it quickly, is just the video. Nothing spectacular or special, but the principle is the same. You only get to see what you're entitled to see. And that is how you do cross-domain futures, and that is how we break this 20-year way of working. It's about rethinking how information moves in those coalition operations. Same systems, same networks. It's just different truths for different users. It's policy and cryptography, not boxes and boundaries. So we have documents, data, and media. We have our handling instructions. We have our audience attributes, and that says who can see it, who can receive it. The problem today is that cross-domain infrastructure is not intent. It's static high-low boxes, one pipe, one classification, one view. It's expensive to procure, it's slow to change, and it's hard to adapt. Oversharing or undersharing is completely baked in, and it always gives you this coalition friction. If they're on the network, they see everything. So we have our documents, our data, and our media. We've either got onboarded recipients with access, which increases our insider threat risks because we're bringing more people up high, or we've got our CDS doing donkey work it was never intended to take things down to other recipients, but then we end up with another problem. At the low side, we have copies of documents, copies of data, copies of media that we then need to try and secure in different ways. That is a significant problem, and that's exactly what I've just shown you how to solve. What about TLS? TLS does for network sessions what we propose for cross-domain data products. It improves forward secrecy and protects sessions, but what I've just shown you extends that logic up one level into data products. So documents, ISR, video, all of it is individually encrypted, sliced per attribute, and only released to authorized parties. And as I showed you, even if network TLS is broken or an endpoint is compromised, each product remains bounded cryptographically and by policy. So that is a massive change. The insight you get from what I've just shown you is that security isn't really about domains. It's about who sees which slice and for how long. If every object is a set of fragments, some open and some restricted, release depends on attributes, not networks. Per transaction, short-lived cryptography binds access. The same underlying box, it's just different authorized views. So the way that I've just shown you how to work, you can have your multi-classification document at secret with one recipient with a handling caveat 5 eyes to go to another recipient, a slice release to official for UK eyes to one recipient, and a slice at official releasable to NATO to another recipient, all without a huge change. So how it works, this on-demand per user per transaction corridor, I've shown you it in the app, but it's really, really simple. You have the documents, data and media, you have your instructions, you have your attributes, and that then keys it to that recipient and expires it on a time basis, then deletes it. So you've got baked in handling. So the user attributes are validated, and that could be their role, their clearance, their nationality, the handling caveat. The system generates ephemeral keys for each request. The object is sliced, so you get document on a per section release, and sanitized ISR track, video overlays added or removed. The fragment is encrypted only for that user. Security benefits, I mean, I probably don't need to go into these because they're quite clear, but let's do it anyway. It's fundamentally a safer exchange model. No standing pipes, no lingering exposure. Every access event is cryptographically distinct. The adversary sees only noise and there's no stable pattern in that. So even if they were to use the most advanced machine learning to listen to your traffic, there isn't a stable pattern for them to get signal from. So over-release also becomes mathematically impossible because of the way that we've designed the system. So that's perfect for mixed trust environments and complex caveats. Multinational operations where you can have NATO, non-NATO, Five Eyes, partners, just UK, ISR sharing. So that's fidelity, minimal fidelity for partners where that's appropriate. Mission video, same footage, different overlays, different caveats, document control. That's sharing those multi-class information documents safely without duplication. And instead of dealing with what are fundamentally Office documents everywhere, we've got structured data. And joint targeting. So everyone within a humanitarian corridor or joint targeting environment would only actually see what they need to do the job in hand. This does have an impact on procurement and architecture because you can stop buying a network per domain and you can start securing the data, not the pipes. Fewer physical domains means less infrastructure, means less duplication, no more twin laptops, no more doubling up on everything. A cross-domain solution shifts from being an overworked brain to almost a dumb encrypted transport box. There's no need for parallel systems. Same box, loads of different views, so you get reusable kit out of this stuff as well. Faster onboarding for new partners because you're dealing with attributes, not architecture. And it's cheaper to maintain and easier to scale. In terms of adversary disruption, and I just touched on it, it's operationally awkward for an attacker because there are no persistent patterns for them to analyze, no static keys, no stable pipes. These short-lived corridors give no useful exfiltration. So compromise of a moment doesn't equal compromise of the system. Coalition friction becomes harder to exploit, and that's something that you could drive a wedge through. So their job becomes harder, whereas ours becomes easier. As you can see here, this traffic between the environments, we've just muted the signal. That's effectively what we've done. And the thought to leave you with, cross-domain futures isn't a product, it's a posture. What this is all about is enabling you to share more, to share safely, to tailor information to mission needs, to reduce cost, to improve tempo, to enable coalitions to operate at the speed of policy and make compromise expensive and very short-lived if it ever happens. So what this is all about is making a domain a deployment detail and not a security boundary. And just think about what else could we achieve if information followed the mission and not the network. Thanks ever so much for listening. Hope you enjoyed that and hope it was food for thought. Have a great new year.